Okay.
Powered water or energized water?
No, I said powered water and vortex
All right.
conservation in agriculture. So agriculture is going to be the overall general theme of this, but we actually have two subjects. One of them is the concept of powered water versus not powered water, if you will, and the other is vortex conservation. So with the overarching thought about conservation as made possible by and through the vortex. That's what I'm thinking anyway.
Okay.
All right. And it's all about agriculture. So that's our context, is agriculture is growing. And maybe I'll make this thought relative to what powered water is in the context of agriculture. And that's really just a simple fact that unless the water, well, rainwater is powered water. Okay, that's probably where we can start. All right. But when it's not raining, then the water is that they're getting from their well, their canals, etc., is really not powered. It may be wet, it may be look like water and somewhat act like water, but it's really not powered. And water that's not powered has some properties to it that powered water does not. Or put it the other way, powered water has properties that not powered water doesn't have. Okay.
Yep.
So we're to
So is energized a better word to use than powered?
I think a lot of people say energized already, so they've already dismissed it. People aren't hearing the word powered. So I just thought powered sounded good. It was fresh. What can I say?
Yeah.
I'm trying to get people's attention, and if they've heard these terms all the time, we got to give them new terms. That's at least the way I look at it, you know. So, but a couple of the things that we can attribute to powered water, and I think are really important in agriculture, has to do specifically. Let's start with evaporation rate. About I found a video. Huh?
Evapotranspiration.
Evapotranspiration. Yeah. Well, the fact of the matter is that if water is flaccid, if it's sedate and it's not energetic, okay, I had to go there. It's energetic. It's not in real dynamic motion. It is more likely to evaporate much quicker. In some cases, as far as spraying, as far as irrigation itself is concerned, especially affected by whatever the heat is, you got a big potential of water coming out of a nozzle and not even making it to a leaf, much less into the ground.
Yeah.
Now, on the other hand, surface tension. We got surface tension changing when it's powered. We got it reducing. We got the molecules smaller. We get more penetration. But when it's not powered, you got higher surface tension. It basically means that the water that comes down that does make it to the ground is more likely going to puddle up and sit there on the surface instead of going down into the soil. All right.
Right, and you know, I think with Arthur that we've got New Zealand that's got those 3 8-inch units and the 6-inch unit. You know, he's working his land same as the farmers around his area, and he said it was hard to tell at first if the vortex devices were making too much difference, but he said and then we started to feed out, then his neighbours started to feed out when he didn't, and he said that told me that we were getting better. He said they were irrigating. He said, but what happens when you irrigate and you don't get rain is you don't have the growth, and there's not the I'm just trying to think of the word that he used. There's not the nourishment in the grass from the irrigated water. So they have to supplement feed, and this is for dairy cows. So they supplement feed. And he said, what he noticed was that they were using irrigated water, and they were still getting the growth that they would have like from the rain-like results.
Right.
But his neighbours were still irrigating, and they still had the same pivots, but they had to start to feed out because the cows weren't getting the nutrition from the grass because there wasn't the energy, and the water wasn't powered as such.
Well, yeah, it also, that gets back to surface tension. It gets back to permeability. It gets back to the water literally not only being a carrier of the nutrients that are in the soil, but it also means that it's actually getting through the root walls and getting into the plant itself. The one other point that I missed is that there's actually more of it. What they were saying by getting rain-like results is that they had spurts, they had more volume of crops themselves. There's more there. In addition to being more nutrient, there was more actual volume of produce. That's productivity. That's what they get from rain that they generally do not get from, or simply not nearly as much, from their groundwater, their well water, etc. So you got unpowered water that may not even make it from the nozzle to the leaf or into the ground. I mean, yeah, some of it is going to get there, but a lot of it is just dissipated and you never even know anything about it. But here we've got water that's now going to penetrate. It's also much less susceptible to evaporation. The evaporation rate of the water, of vortex water, of powered water, is less. It will be there, and it holds itself together much better. And on top of it, it penetrates, and it gets through the root wall, so it delivers it gathers its goods, and it also delivers it. I'll give you another example that we have a customer who bought one of these little units about 4 years ago. He's in Southern California. He's in Anaheim, and he started calling me again. I hadn't talked to him for a couple of years. He doesn't, and he refuses to write this stuff out. He said he doesn't have email, but he's got a phone, so he'll call me. But he bought the garden unit around the time that that the drought was on everybody's mind in Southern California, and he used it on his lawn. So he still, watered his lawn, but it was vortexed water, and that lawn had gone from brown. They can romanticize the brownness and call it golden. It's the golden state. No, really, it's the brown state. Okay, it's got a little different take to it now. It's not so lustery now. It's brown because it's not green. Okay, but he used powered water with one of these little garden units, and that lawn became nice and green. Didn't use a lot of it, but it's still that the grass greened right up. And then after some time, he discovered that now other things were starting to grow that he didn't plant. Like a tomato plant started to shoot up. He hadn't planted any tomatoes, but the water is literally activating seeds and nourishing, and it's bringing an energetic quality that is, you can't measure it, so you don't typically know it's not there if it's, generally speaking. But here, the plants start knowing when that quality is present, and they start responding.
Yeah.
So that's one of the good things.
I have a similar thing in Perth with one of our customers in Perth that bought a whole home unit. You know, I said to her, just wind your retic back until it doesn't work. And now she, you know, now she's using 66% less water. And she said, the lawn and gardens never looked so good, and I'm using 66% less water, or one third of the water she was. I don't know. I'm not the mathematician in the house, but you know, she's using a third of the water she was, and she's got healthier lawns than she's ever had.
Well, that's the thing. Now, you also, in mentioning the farm in New Zealand, I wanted to ask, did he cut down his water amount too?
He didn't cut down his water amount for the pure and simple fact was they were loading the soil. So what happens is if they don't have any rain, what happens is that their allotment of water because they're on a scheme water system, their allotment gets knocked back. So whilst he had access to water, he was just like loading. So he said, I probably haven't done the right thing by you guys in regards to giving you some information about how far I could wind it back. He said, because I didn't know, you know, whether we were going to be put onto restrictions or not. And he said, so I just wanted to load the soil up as much as I could.
Okay. All right.
So he did not, for that reason, he didn't knock it back.
He'll be a biochar conversation one day if he wants to load it up and keep it. But that's another dimension to it all. Well,
no, I did mention that. I did mention that to him, that it's something that he should look at, that biochar, because he is putting humates in the soil. And I said, what point is there putting humates in the soil if you've got no carbon to hold on to them, buddy? He goes, well, what do you mean?
Oh, well, there. So okay, Junior, let's sit down. Let us talk. That'll be good. Well, now here's the other thing. So we got the idea of powered water, and now the other part is vortex conservation. And what vortex conservation basically are those properties, those proclivities of a vortex that make it possible to actually use less water and yet get more done. I think that's kind of really what we're talking about. I mean, and that's all, but this vortex event basically allows that to occur. Now, part of that has to do with the water. What is done with the water itself, which we start talking about the physical changes to the water, but it's not just the physical changes to the water in the case of surface tension and evapotranspiration rates, permeability, infiltration, and those things, deliverability, but it is also how first of all, everything that's in the water is also changed. And so the water physically, because of the vortex action, it causes, well, these would be radial. You know, if you can see my fingers as radial, and some are going in this direction, some are going in that direction. There are flows of water that are going in opposite direction, or flows of particles that are going in opposite directions to each other. And as Alex has pointed out, water unto itself cannot be compressed. So when you fill up that body, that internal cavity, that water, there's nothing, if there's no more room, it's going to start grinding down anything and everything that is within it. So all the particles. This causes the particles to be smaller, the clusters to be smaller, but it also causes for a far more complete distribution of all of the material that's in the water itself. So and that material can be fertilizers, it can be various types of um, uh, amendments that are necessary to actually help the plant grow. So it's going to be present. It's going to be well and fully distributed within the water, within the body of water, and it's going to be at an optimal size in terms of small, and it's going to be able to be delivered again through the root walls. I mean, and it's fascinating because we've got these flow forms and stuff in it within the system, but it is basically making all these changes within the water itself and making the water much more able to deliver. I mean, I started thinking about what these amendments cost, uh, a farmer. Now, in some cases, they're paying a lot for these farmers, but for these amendments, or in some cases, they've got animals, they've got cows, they've got sheep, they've got chickens, whatever. They all cost something. None of it is free. They have to keep. They have to care for these things. Oh, there's another thing in terms of powered vortex water and vortex conservation, where we see that animals, whether they're cows, whether they're chickens, they eat less, they even drink less, and yet we see growth rates.
I've got those. I got those stats from the chicken place in New Zealand, and they use 50% less water. They eat about, I'm going to say on average, they eat about 10% less. But they're like physical daily stats from sheds and sheds of little chickens.
Mm-hmm.
And it's pretty much half the amount of water.
Well, in places where water is either scarce or expensive or both, or where the quality is, I'll say, marginal. I know certain cities, municipalities, certainly here in this country, where they're now making an entire market out of what they call, it's not treated water. Reclaimed, that's the term. They call it reclaimed water. But it's another way of saying highly chemicalized, but it's not restored. It's chemically treated, and then it will be in its own, like reservoirs sometimes, where they'll pump it to a certain location. And then they've got signs out there saying, don't get into this, okay? Don't swim in this, stay away. But they're going to use it as irrigation water, and so put it in the ground, put it in the plants.
To feed the plants and animals that you're going to eat.
Yeah, it's amazing to me, the logic. And see, the first thing about this is that people, they end up congratulating themselves for coming up with this great idea to call it reclaimed water, and they paint the pipes purple. But they're selling, I mean, they're not giving this stuff. They are selling this. I mean, they're charging the growers for this water, and it's substandard. And yet it's okay to use it to feature animals that eventually become someone's food. It's really amazing. So vortexing is a way, and I'll say it, I can't and don't know, as we've been around this subject, I keep getting these, kind of insights that are somewhat off book, so to speak, off the book of water, but it really started to make sense the more I would learn about water's properties. And also, there is a term, we talked about this once, called auto-ionization. And what that basically means is that the vortex event is literally creating proton and electron clouds. It's producing new charged particles. I remember in my first days talking about biophotonic and photonic action. This is one of the effects of creating, or should I say, spinning this water body up and creating this this phenomenon. A vortex is basically a phenomenon of nature. It's not something that's mechanical in the sense that, you know, we're creating a dynamo. We're creating a natural result from the flow and from the dynamics of the water in terms of how it spins. And in that center, there are these tremendous differentials of pressure because the body itself is sealed up. There are no leaks in the body at all, and there's a body that's also strong, so there can't be any compressibility. There are tremendous pressures, very large differentials, and this is what causes electrical activity to occur, just like lightning and just like thunder. And this is how and why water can destroy pipes, you know, if not right. They have this thing called water hammer and other things. These are very, very strong, very powerful forces. And we simply are putting them in a place where they can do some real, I want to say, dissociative activity on what's in the water, and then allow what's there to be recombined. And I sometimes like to say repaired. But it turns out that nature will put like with like, compatible with compatible. And in so doing, we see some just amazingly beautiful and beneficial changes as a result.
Absolutely. You know, back to that farmer in New Zealand, like something I didn't mention before was that the amount of electricity used for his pumps. He said, you know, that was the first thing he noticed. Instead of pulling 34 amps, his pumps were now only pulling 27 amps.
Oh.
So, you know, that's a pretty big saving.
You remember a year or so ago, maybe 2 years ago, someone was asking us about frictional loss. And of course, at that time, it was a term we had never heard of.
Mm-hmm.
Well, that right there is the effect of a reduction in frictional loss. I mean, the water is wetter. There's less friction. It's more fluid, super fluid, you might want to say, and the pumps are working less. I mean, we didn't have to predict it. He noticed it himself. Of course, we probably wouldn't have thought to at the time, but that's good to see.
Oh, he noticed when he first cranked the pump up, because what he noticed was he could talk in the pump house he could speak to his son in the pump house. He said it's always been too noisy to talk in the pump house.
Wow.
And he said that just told me it wasn't pulling as hard. And he said then I checked the amperage, and it dropped from 34 down to 27 amps.
Wow.
Now, on that note, I have to go and pick a little guy up that's got way more energy than I do. He's finishing up at school this morning, so I need to go and pick him up.
All right. Okay. So well, it's a good visit. And this is a good way to keep us on track in that regard, too. All right, Jody, well, you check out. I will talk to you later. We'll get this up and we'll share it. Anyone that is interested, give Jody or I contact us. Oh, and just for anyone also, just so they know that we have ways to, if it would help, to make a purchase on installments. One of our merchant services companies can actually do installment purchase. So just ask us about it. We can let that happen too, for up to $10,000. So just so you know. Anyway, Jody, go get the man, buddy. And I'll talk to you later.
All right.
See ya.
Thanks, mate.
Bye.
Bye.